anyone joining can see this later. Right, I should probably share my screen. It's important that you guys actually see something. So, last time we started on an example of classes and how we can use them. So we had this mini game here where we wrote a game object class along with a position struct that went along with it. And we gave it a few variables. We gave it a character for printing onto the screen. I should probably pull up the chat too. Alright, there we go. Yeah, we gave it a character for printing onto the screen. We gave it that position, which was just its XY coordinates on the screen. And I have formatted it in my code so that it works like standard math where, 0, 0 is the bottom left. We started giving it an ID, but we didn't get very far with that. And then we went over accessors and mutators. So accessors get private variables and mutators set private variables. And then we wrote a couple functions here, and we implemented them in a C++ file or in the class declaration here. You'll notice that I was able to implement a few in the class declaration, which we can always do. Or we can do it similar to a function prototype. We can just give it a name here. So again, just to remind you, we had move and bounds was a game object function that belonged to game objects, and I declared that right here, but I didn't write a body for it. Similar to a function prototype, I just gave the name and the parameter list, which in this case was nothing, and then I was able to write it here, somewhere else. And the way I specified that the function I was writing belonged to game object was with this : scope resolution operator. So that's just a refresher of last time. And this time, I feel like we should talk about a few things and then maybe go over assignment 2 a bit. So just remember, assignment 1 is due Friday, I believe at midnight, or 11:59, if we want to be pedantic. And then, remember to turn that in. Assignment 2 is due next Friday, and we'll talk about that in a little bit here. And there is also a video I posted on Canvas and in the Discord. So I encourage you to look at that as well if you haven't already, because it explains the general program. But I did change a few things to hopefully make it easier. Okay. So perhaps we should talk about static scope. So in this game here, I was creating game objects, right? And in my simple thing here, my main program, I created a player game object and an enemy game object. And I would generally, in a real game, probably end up throwing a lot more things in there, maybe enemies, items, and all that. That would all be instances of a game object. They needed some sort of visual representation. They share something in common. So perhaps it would be useful for me to create something that keeps track of how many objects I have, along with the ID, which I created last time, that helps us identify the actual game object, because we could do some sort of lookup, in some sort of data structure that is based on the ID and quickly gets things and helps us with efficiency and all that. So it might be helpful for us to both keep a count and keep an ID. So one way we could do that, which might be the common sense way right now, is to just put like an int count equals 0, and then every time I create an object, I could do count plus plus, count plus plus. So when I print this, I should just get cout game object count. Oops. Count line. This would just print the actual game object count, right? So if I print this, it should be 2, because we have a player and we have an enemy. Wherever the window is, there it is. Right, so this is game object count 2, which is what we expect. But the problem with that is that, A, it's kind of annoying to write. right? But B is we can actually make things a little bit more organized if we were to associate this count with game objects themselves, because the only thing we're ever going to be counting is a game object, right? Okay, so maybe a better idea is to take this count and move it here. And actually, I guess maybe one thing to notice is I didn't even set the ID properly, right? So these wouldn't even have any unique IDs with the way I had it set up. So I could create an int count at the global scope, and then do something where maybe in the constructor here, I say, oh, well, make the count go up because we created something. Count is ambiguous. Why? Is there not only one? Maybe it doesn't even let me do that, which is fair. It probably shouldn't. Okay, so globals are out of the question, which is good because we shouldn't be using them anyways. So next question is, like, where can we put it if we want to associate it with the game object? So, I think the obvious answer might be to be here. And I can't really initialize it with 0. I'd have to do that later. And then I could obviously make count plus plus go up. So I can make count go up like that. And then I could do the same thing in this constructor. So whenever it creates a new game object, it makes the count go up. And then maybe before that I would... actually, let's just, for the sake of good programming practice, let's move this somewhere else. Let me do a private variable, because we only need it in the game object, called void generate ID. And what that will do is it will just set the ID equal to the current count, and then make the count go up by 1 because we created a new game object. Right, so if I was to start counting at 0, this will make the first game object 0 because the count will be 0, and then it'll make it go up 1, and then when I read in the next one, that will get the ID of 1, and then we'll make it go up to 2, and then the next one gets the next number, and so on. So I can just throw that in here now. Generate ID. And this is an example of where a private method might be a good thing, because I don't really need any other part in the main function to know how this works, right? So they don't even need to use this function at all, which is why I'm probably good making it private versus public. So there is some utility in actually making private functions. So generate ID. Okay, and there's going to be a problem with my code, you'll notice. But yeah, so this should generate an ID now, right? Okay. And we'll just say player.count so we can print it. Because it shouldn't really matter which object we get this from, right? Oh, and I have the count as private, which I probably should, so let's just int get count. And then this will just return the count. So we'll use an accessor for that. Actually, let me make sure everybody's getting in class. No messages? Okay. Hopefully everybody's here. We got 23, that's like 70% of the class. But yeah, let's just throw that get count, and then we'll call that in main. Okay, so if I was to run this now, it now counts it whenever I do a constructor. So this will make the count go up, and this will make the count go up. So what do we expect to get printed? I see a 1. Okay. Anybody else think 1 or maybe 2? And if so, why? Is there a reason that you think 1? Right, yeah, you got it. So I'm just printing the players count, right? And they both have separate counts, so ooh, that's not good. I I've tricked you. It's not even 1. It's negative 8,000. That's because it's getting initialized to garbage. That's my fault. Where did Visual Studio go? There it is. Yeah. But you're right. It would print 1 if I properly initialize count to 0 at the beginning. Yeah, so the problem with what I have set up right now, I'll pull this open, is that the count only belongs to every specific instance. So the enemy and the player and maybe any other object that I would be adding into the game aren't sharing the same count. And we were trying to do that with a global earlier, but you would notice that the compiler wasn't happy with that. And we shouldn't be doing that. So there is a way to attach it to a specific class so that they all share the same variable. Or also, we can do this with functions, as you'll see in a little bit, because I'm going to have to change this. So, yeah, what we want here, I'm just going to pull this up, is we want them to all be able to access the same thing, but we, oops, that's on the wrong screen. So we want them to all be able to access the same information as long as they're in the same class, but we don't want anybody outside of that class to be able to access the count. So the problem with putting count in main is that, one, we're not really attaching it to the game object, even though it's associated with it. So there's that idea of cohesion in object-oriented programming where we try to put associated data in the same class or struct, like the same package. And then there's also the fact that anybody could access it. So if I made another class, it could also access that game object count and do something with it, which is not particularly good if we were to just put it in main. So the idea is we want a object for the game object where every single type of game object, so the player, which is a game object, and the enemy, which is a game object, we want them to have their own code. We want them to have their own update and ID and position and all that. So we want them to each have their own that they can look at whenever they go to look at it. So the player can see this one and the enemy can see that one that belong to themselves. But we also want them to share a variable. So I want a single count that all game objects can see. Okay. And I can also do this with functions. So I can make functions that all game objects, it affects everything that they have. And the way I do that is with static scoping. So this stuff here that belongs to each individual instance is an example of dynamic data because it's dynamic. It belongs to a specific object. You can modify it just for that object, and its placement has to do with that object. But static things are things that just kind of sit there. They don't belong to any one thing, and they are they're shared essentially. So let me close out of this. Hopefully this makes sense. Any questions on what I'm going for so far? Everybody accessing one variable, as long as they're an instance of this class. Close that out. Keep closing that. Okay, so the way we do that is with the static keyword. Okay, so I have static int count, and now it's a good idea for me as well. So even when I called that get count earlier, actually, I'm going to leave this here just for the sake of the example. We'll come back to this in a second. But now it's static, which means that when I do this count plus plus, it should go up for both of them. And one thing I should do before I move on is, let me just make sure I actually set it to 0 this time, which I can do now because it's static. So the way you have to initialize static variables in C++ is you have to go into a global scope and give the scope resolution operator to say what it belongs to, and then actually set it. And I think you also have to redeclare it with int. No, it actually lets me do that. Nope, I do. I was right. Which is a kind of a strange syntax to me. For some reason, if you try to just set it equal to 0 here, It doesn't seem to like that in C++. I'm not exactly sure why they do that. It must be a const, and it kind of is. Oh well. I mean, it's a literal, but... so the way you have to, unfortunately, do initialization of static variables in C++ is you have to go to global scope, provide the data type, scope resolution operator, and then the variable itself. No idea why they don't just let you do it here. That's the way it works most of the time. But anyways, I digress. We've initialized it to 0 now at the global scope, and we are creating two game objects, so it should make the count go up each time, right? So is this still going to print 1, or is it going to print 2? Because if you notice, I'm still calling player.getCount. So should it still only print 1? Still print 1? Let's take a look. So if I run it, something is broken. Prints 146, which is definitely not right. The question is why? Why is it doing that? I don't actually know. It doesn't make a whole lot of sense to me. But let's just look at the debugger. So by the time we get here, it should be 0, hopefully. So I have a player. I'm going to create the player right now. And we see that this has no ID yet. It doesn't seem to show me any statics, which is kind of an issue. So initializes that, initializes this, goes to generate ID, and just skips out of that. Did I not hit step into? Then we go to do the game object, and it sets the symbol, generates ID. What exactly is happening here? Is it going to print different garbage this time? No, it's still 146. I don't know why that's happening, actually. That's very strange. Did I do something stupid here? Let's just see out the count. Count is... It's kind of ruining my example, but hopefully, if it doesn't run, I'll tell you what it should be. Cout is not a... so I'll put that up here. I'm just going to do it this way for the sake of not having to delete as much. Okay. No? End line. Oh. Standard end line. There we go. Okay, so let's check the window. Yeah, something strange is happening. It's getting called a bunch. So I've obviously done something strange. The question is, what exactly is happening? Am I blind? Why would this get called multiple times? If I'm missing something, let me know. Why would that get called 200 times? I must be crazy. Well, this it's getting called like 100 times. I'll open the debugger too. You can see it's printing 144 times for one of these variables. I guess the player. It's getting called up here, but I'm not instantiating any game objects. Might just have to look into this later and explain what it should actually be getting. I don't quite understand Let's just do one thing really quick to see if we can fix it. I don't want to spend too much time if my code is just broken for some strange reason. So if I run that, yeah, what is calling this? Yeah, we're just getting some random garbage calling this. Oh, I know what it is. I know what it is. I got it. I understand. I'm creating this game object screen here that's an array, right? Yeah, so it was 144, and my resolution of my screen is 16 by 9. That's why. The resolution of my screen is 16 by 9, and so that 16 times 9 is 90 plus 54 is 144. When I create this, it's calling the constructor on every single individual element of the array. So let's avoid that really quick. Okay, that makes sense. So C++, I guess one thing to note, yeah, it's counting the spaces. That's the problem. Because I do have those as a game object just for the sake of it. Yeah, one thing to note about C++ is it automatically calls your constructor even if you haven't tried to call a constructor, which a lot of other languages don't do. That's just something very important to consider. So that's why it wasn't working. So I think what I'm just going to do is, from this default constructor here, I'm just not going to count the ones with spaces. We're just going to ignore those ones. Okay, so now for real, we should figure out what it is. So let's run it. So now it should just count the player and the enemy. There we go. And so now we finally have an answer, and it's the correct answer, which is 2. So why was this 2 instead of 1? Well, hopefully it's what we expect. The player makes the count go up, and the enemy makes the count go up. I think maybe the point of why it would have been 1, or the assumption that it would have been 1, may have had to do with this, right? So player.getCount. So the thing to consider is that when I go to get the count of the player and the enemy are now counting to the same variable. They're both counting to the same count. So whenever I access it, it doesn't matter if I do it from player or if I do it from enemy. You'll notice if I change this to enemy, it should still print 2. They're both talking about the same variable. So when I go to get it, it should be the same variable. It should have the same value. Does that make sense so far? Obviously, this readability is not actually good, and I'm going to fix that. But I just wanted to do it for the sake of an example. So it actually doesn't matter what object I get it from, they're all going to get the same count because they're all sharing it. And that's what static variables are, is that they don't belong to any specific instance of a class, they just belong to the class in general. Any questions on why that works? Okay, fair enough. If you have any questions on it, just stop me. So, yeah, maybe the point of confusion on that one, why it might have been 1, was the fact that I was accessing it from a player or an enemy, which is not a great way to do it in practice, but it's totally realistic. We can do it if we really wanted to. So when we do an accessor for a static variable, or use a static variable in general, what we should also do is use a static function to access it. So what I'm going to do here is I'm going to change this getCount to a static variable, and now you'll notice no compiler error. It will grab it. So I will get a compiler error here because I am trying to, at least it should give me a compiler error. Right, if I try to run this, it should tell me that I can't access getCount with a static reference. No. Wow. Okay. I guess that's unique to C++. So apparently we can still call this static function with a instance, with an enemy or a player. So I guess it still allows that, but you shouldn't be doing that in practice. That's not good for readability, at least. So what I'm going to do instead to get the count is I'm going to access it the same way we've been doing the rest of the accessing from GameObject. So I couldn't have done this before when it wasn't static, which is I can just say call the GameObject function called getCount. So if I have a static function, because it doesn't belong to any specific instance, I am allowed to just call it with GameObject, which is convenient when you're programming because maybe I don't have access in whatever function I'm writing to a specific GameObject. So maybe if I was writing a function down here like clear screen where I have all these GameObjects, I might not have any individual one GameObject that I want to pick to get the count from, and in fact maybe it's just completely empty GameObjects that don't actually have access to the count or something like that. So in that case I should be using the static version of it because it doesn't really make sense to get it from any specific instance, if that makes sense. So now if I print this one, it should also be 2. Which the window would spawn on the right. Okay, there we go. And it does print 2. So we can access any static variables in a static scope using that scope resolution operator and the class that it belongs to, or struct. Now there's probably one last thing I want to address with regards to this, which is, let's say I wanted to make a static variable static function that got the ID, let's just say, of an object. Int get ID static, let's call it that. And you'll notice, oh, whoops, return static. Return ID. You'll notice it tries to give me an error there. So why am I allowed to access count but not ID in a static function? Consider that static means that it's just it's free flowing. It's not attached to any instance. So if I try to access an ID is attached to, in this case, the way I wrote it, ID is unique to each individual instance that I create. So the player, for instance, gets their own ID, right? And the enemy gets their own ID. And if I was to create more GameObjects, more items, then they would each get their own ID. Oh yeah, and somebody said it. ID is not static, right? So ID belongs to a specific instance. So if I try to do something here where I just say get the ID, but I don't say what to get the ID from, whether to get it from player or enemy, it doesn't really know what that means because each individual object has their own ID. Let me just draw this out for the sake of the example. So again, if I do that example that we had earlier, I might have a player here, and so the player has an ID, and a character will just say, and then the enemy has an ID and a character, and they both have the ability to look at a static variable called count that just belong to the GameObject. And so I had get count over here, right? That just got the count. So these were some of my static things over here on this side. Again, meaning that they just belong to the GameObject in general, and these things were dynamic, so they belong to any specific instance. So whenever I call a static variable, it has access to anything else that's static. But when I call a dynamic object, it has the ability to look at anything that's in its dynamic scope as well as the static scope. So here we have this arrow pointing to it. So if I was to call get ID over here, that just gets the ID, it's not going to work. And the reason is there's no ID for it to see. So if it tries to get the ID, well, it can only look at static variables that it has access to, which is the count, and get count, which is a function. So it can't actually do any of that. But if I was to do it over here, for instance, give each of these their own version of get ID, then that's totally fine, because it's right there. They can see it. And I'm also allowed to do get count, because even though count is not a dynamic variable, whenever I call something in a dynamic scope, it is able to look at its own variables as well as any static variables. So it can point to everything in the game object class. Is that clear on what things dynamic functions are able to look at and what things static variables are able to look at? That's the general rule for it. There might be more technical or specific things, but that's the general overview, or that's the way I usually think about it when I'm writing it. Okay. So, if we don't have any questions on static variables, I think I'm going to talk about assignment 2 for a little bit, just because we don't have class on Monday, and I think it would be nice for everybody to start over it while we have a day off. Okay, so I have it pulled up already. Let me move this over. Okay. So the general idea for this assignment is that you have a rocket ship for some company called You Can Fly to Space that wants to send everybody to the moon. And they have 4 types of rockets: cold gas, chemical, thermoelectric, and hybrid. And what we want to do is we want to keep track of data about each of those rockets and then just launch them into space. So I'll let you read all of this here. It's basically... Actually, let's talk about it a little bit. It's basically what I just said. So there's the 4 types of rockets. We're going to launch them into space, and we want people to be able to buy tickets for that rocket. So what you're going to have to do in their simple output is ask a person, so start off with the program. You want it to prompt the user as to what the capacity of each rocket is. So rocket 1 might be... Where's the scroll bar? Should be in the sample output here. Yeah, so you want to prompt the user exactly what rocket or what capacity you want each rocket to be. So the cold gas rocket in this example was 2, 3, 4, and 5. And then you want to prompt the user to fill in those seats. So here you want to ask the user, and I guess also account for the ticket price, which we'll talk about. You want to prompt the user what rocket do they want to go on. So for instance, this person typed in 5, 6, and 8, which is not any of the options there, so it just does nothing. But let's do a more interesting run. So this person said rocket 1, so they selected the cold gas rocket. And then you want to ask them how many tickets they want to buy. So available seats are 2 in this case, because the user entered that the capacity of it was 2. And then basically have them enter all of their information. So for every passenger that you have in the rocket ship, you are going to want to ask for their name and then their status. So we have 2 types of status here. The passenger can either be a veteran or a non-veteran. And veterans get a 10% discount, and non-veterans will have to pay the full price for the ticket. So by the end of this, okay, so I think this is just testing for incorrect input. So 1 was veteran, 2 was non-veteran, and this person entered 4 and 8, which shouldn't do anything. And I think he cut off his code or his output there. So let's take another look again. So this person types in their name. They wanted to enter just one passenger, and they selected that they were a veteran. So their ticket price should be 90% of whatever the original was, and you should print out how much their ticket price is. So you should only have to do this on a person-to-person basis. So whenever you ask for a new passenger, just ask for their name, ask for whether they're a veteran or non-veteran, and if they are a veteran, print 90% off the ticket price and full price if they're a non-veteran. Okay, so let's just look at the sample output. And this will hopefully make more sense when we actually go look at the code here. And then after all of the actual passengers are taken, or if the user decides that they want to actually fly the rocket, we're going to fly the rocket. Actually, I guess as an aside, you should also make sure that if the person is trying to book tickets, that there are still tickets left. So if for some reason the person on that first rocket, so the first rocket only had 2 people in it. If somebody said, oh, I want to buy 5 tickets, you shouldn't let them do that. So make sure you're checking that the amount they're entering is less than or equal to the amount of tickets left. Okay. So the way we're going to set this up is through a few classes. So the first thing we're going to have is a rocket class, which just holds the rocket as well as some data on the rocket. And what Dr. Chigella has set up here is a UML, Unified Modeling Language diagram. We don't need to go into like the specifics for it, but the things to take away from this is if it has a minus by it, that means that it's a private variable, and if it has a plus by it, it means it's a public variable. And each of these are just the type of it. So if I was to code this up, I would have class rocket with an int called ticket price, and it's a private. And then anything with left parenthesis, right parenthesis is a function call. So we'll have a rocket that keeps track of just various data, the type of fuel it uses, the name, the time required to get to its destination, how many seats it has, all that stuff. And then we'll need some accessors and mutators to go along with that. So a way to set and get the velocity, set the fuel capacity, set things in general. I think most of those are pretty straightforward. And I do have comments in the skeleton code that explain it a little bit more. And then we have a passenger, and the passenger just has a name and a type, and the type is just veteran or non-veteran. So we just need a way to set the name of the person, get their name as a string, and I've modified this a little bit. I've added a way to both get and set the actual passenger name, or sorry, passenger type, veteran or non-veteran. So if you need to get it, you can always go back and get it and figure out what it is so you can determine if they need a discount or not. And then this one I think is a typo. This is meant to be menu. So we want a menu class as well, and that's just in charge of printing everything and getting the input from the user so that we can actually do some things here. And that just has 2 functions, show rocket menu, which shows that menu that we saw earlier where it's just showing what rocket you can select, 1, 2, 3, or 4. And then a constructor for the rocket that basically just prints a message up at the top. And I think he's already done that one for you, so there's not too much to worry about that. One other thing to notice that we haven't gone over yet is that there's a const after some of these functions. And all that means is if you put a constant after it, it means you can't modify anything whenever you call that function. And really the only reason that's a thing in C++ is to just be assured that whenever you call a function, it's not going to change any of your variables, so you can be 100% sure that when you call it, it's not going to do anything to any private variables, and it's going to stay the same. So something like get rocket specs, that makes sense to be constant, because all it's going to do is return the values of the rocket. Okay. Let me just have some brief descriptions of these. And I won't go over these, I'll let you read them on their own. And I do put comments in the code for all of these. I did add that to the skeleton code so that you can kind of get a general idea. So I think we'll just take a quick look at that, and then we'll see if anybody has any questions on it, and we'll take it from there. Okay. So this is the skeleton code. It's up on Canvas. If you downloaded it a few days ago, make sure to download it again because I did update it yesterday to add like one or two things. I think I added these two functions because I don't think they were named correctly, and I maybe added one or two more comments. So I put a comment by pretty much everything, just explaining what it is. So we have the passenger class here. We have the rocket class here with all of these functions and a constructor. And all the constructor should do is it should just initialize the amount of seats that have been booked to 0. So the rocket should have a private variable here that just keeps track of how many seats have been taken so far and how many seats it holds in total. Do we need to have a header file for this assignment? You don't have to. For practice, I would say it's a good idea. I would throw all of this stuff from here to here into a header file if I was you, or maybe even 3 header files if you really want to. But I'm not going to grade based off of header files. Although you should for practice because it's good. It helps you organize things easier for like big projects, so I think it's nice. Yeah, so I don't think I'm going to go through all of these, but he's already written the rocket constructor for you. So again, remember this just means that the constructor belongs to the rocket class, and all it does is set the book seats equals 0, and then you'll set all the other values by yourself down here. So just to show what's in the main body written for you already, he calls the constructor for the menu for you, so that just prints this header here. It's like just says whatever title that you give it. And then we have a couple things. So we have a vector full of passengers. This is where you'll store all of the passengers for all the rockets. We have 4 rockets, so even though they're not labeled very specifically, these will correspond with the project here. So when you're filling this out, just refer to this table that he gave. So rocket 1 is the cold gas rocket, rocket 2 is the chemical rocket, thermoelectric, and hybrid. Normally I don't like you hard coding things, and I'd rather you read it from a file, but in this case we actually just are going to read it straight in. So what you're going to have to do is set all of this information from the table. I have so many windows open. So I've written a general outline for you here so that you have an idea. So you use the mutators to set up all the rockets. So basically you want to use all these set values, the set velocity, set fuel capacity, set rocket specs, all of those, to set all of the values from that table on rocket 1, rocket 2, rocket 3, rocket 4. A little bit tedious, but hopefully that one should be pretty straightforward. And then you want to print the rocket menu, which you'll have to implement yourself. So we do have that menu class right here, and it had show rocket menu. And so it should return the choice that you got from the user, either 1, 2, 3, or 4 for the rocket. And then you will do something with the rocket depending on that. And I'm going to give you a hint. I know I've told some of you before not to use a bunch of if or switch statements when doing things like this because it's good to be ambiguous or abstract with your data. But in this case, you should consider hard coding like object 1, object 2, object 3, object 4 based off of the choice. Just because we're specifically doing these here. Normally I'd say that's a bad idea, but that is what we have. Okay. So basically you just want to get that choice from the user and then determine how many tickets they want to buy, and then for how many tickets they want to buy you just need to get the name and the veteran status for each of them and then display the ticket price after each individual passenger, whether it's 10% off or whether it's just the original price. And then we do have one last thing that I haven't shown yet, which is after the user is done inputting things, we want to fly the actual rocket. So that's the only part that you're actually going to need to do any sort of like crazy calculations. This one, hopefully everybody is pretty clear on percentages. And I recommend just making a constant. I don't think he's done it for you, but I recommend just making a constant that holds the % off that you want. So let me open this one last time. So the last part is once the user has told you that they don't want to add any more people, then you're just going to fly the rocket. So for instance here, we want to post that the distance traveled after 1 hour is 2,500, distance travel is 50,000, 7,500, so on and so forth, until it hits the travel distance, which is a constant that he had in main here, and we just want to go until we hit that. So you'll notice it goes up by 2,500 every time, and then cold gas rocket should pass it. Oh, this is the remaining distance, yeah. So we start with that amount of distance, and then you just subtract it as you go until you actually hit it. Right? So you basically just want to check, is the distance traveled greater than the actual distance it's supposed to fly? And the way that you'll determine how far it's flown is via the velocity that you're setting here from the table. So when you set this velocity, just remember your basic physics, right? Distance equals, velocity equals distance over time, right? Or like rate equals distance over time. So, I mean, I'll let you do the algebra, but, you know, the rate in this case is velocity. The distance is the constant you're given, and the time is just how many times you've gone through the for loop, because we're just doing it by hours. So, you know, make it go up every single time by that velocity until it hits the thing. So this one I do think is a bit more difficult than the first one. So if you have any questions, just let me know. There is also like a whole 20-minute video, I think, explaining everything, and I didn't go through all the comments, but I did comment everything, I hope. If I didn't, you know, yell at me and send me a message on Discord or an email or something. Any questions on any of this stuff? It's due next Saturday at midnight. Okay. I don't see any questions, but if you have one, just go ahead and ask. And we'll get back to actually this stuff. I just wanted to spend a little bit more time going over this one than the last one because I don't think it's as straightforward. Okay. Well then, we'll probably spend the rest of the class talking about namespaces and maybe some inheritance stuff so that we get a little bit ahead. Alright. So this whole time you've been programming, we've just been telling you, oh, throw using namespace standard up at the top. It is just useful. It does stuff. But never really explained what a namespace is. So I wanted to take a little bit of time to just talk about that and how you can make your own namespace. So what I'm allowed to do, if I wanted to, is I could put all of this in a namespace. And the reason you do this, it's not highly encouraged when you're doing C++. It's not used in practice by C++ programmers. They don't usually use namespaces. In fact, they don't use standard typically either. But I like to use them, even though it's not conventional. You can declare it just like you declare a class or a struct, where we put namespace and then we put the name in the namespace. So for instance, here I might put namespace game. Okay, and then I just put a curly brace and then I throw another one down at the end. Okay, and I probably need a thing there. So it shouldn't be throwing anything. Cool. And so now what this does is it just says all of these belong to the namespace game. So if I go back to CPP, there's probably a bunch of errors. It doesn't know what any of these things are anymore. And the reason is because I'm not using the namespace that they belong to. So using namespace game should resolve that. So I can use multiple namespaces even though we've only been using one. And all that does is it says all of these things belong to the game namespace. versus if I do this, where I remove standard, you'll notice I probably get some errors on cout. So cout and endline and all those have been in the standard namespace this whole time. And what a namespace basically is, like its name sort of implies, is it's a space of variables. So when I do that, it just says everything that's in this namespace can only be accessed when I'm using that namespace. So when I got rid of using namespace standard here, I lost the ability to use cout and endline and cin and all that stuff. Now, you don't always have to put a using namespace if you want to do it. You do have the ability to use that scope resolution operator that we've been talking about, and that will just basically say, oh, it belongs to this namespace. So the reason you use it is just mostly for convenience and the ability to like turn off or on variables at will. So there's obviously the thing of like, why wouldn't you even want to use namespace standard or like use namespaces in general? Because, like I said earlier, C++ programmers don't actually usually use namespaces. So if a namespace just basically lets you pick whether or not you can use variables in that namespace, the reason that we don't use it is if I have two namespaces that use the same variable. So if I, for some reason, so namespace standard, that has cout in it, right? If I, for some reason, wanted to make a variable here called int cout, which it should let me do, you'll notice I get a whole bunch of cout is ambiguous. And so this is the reason that we don't generally use namespaces, at least like in this regard, is because we might get an ambiguous reference where now, when it goes to do cout, it says it's ambiguous, which means that it doesn't know, am I talking about the cout that's in standard, or am I talking about the cout that I've just put in game? And it can't really know the difference unless you specifically tell it. So the reason why C++ programmers don't use it is because they want to avoid ambiguity, so they always, at least from what I see in practice, put the actual namespace that it belongs to in front of it. So they say, oh, cout, that's in the standard namespace, so I'll put that in front of it. Whereas if I wanted to, print out the cout that I just named, just named it as an integer for whatever reason, because I, hate making readable code, I would have to say game count endline. Oh, sorry, cout. And it says it doesn't have it, but it... Oh, that's because I didn't actually put it in the namespace. There we go. Yeah. It's followed by a class or a namespace name. Is this just not allowed? Maybe I should make this a constant. Oh, duh. This should be allowed, right? Yeah. Okay. Sorry about that. Yeah. So now it'll say that it knows that this cout that I just wrote belongs to game, whereas the other cout was part of standard. Any questions on a namespace? It's really just a, like the name implies, it's just a space of variables, variable names at least, that you can use. And you can turn them off or on at will, or access them using the operator, the scope resolution operator. Don't see any questions, but again, if you have any, just stop me. I'm going to throw this namespace out because I don't really want it. Actually, you know what, this is fine. Let's just use the namespace for an example. I'll put it there using namespace game. I'm just going to remove that cout just so it's clear. Okay. And part of the reason I bring this up is because a lot of the time when you look at the compiler messages or you go on Stack Overflow or whatever, and you're trying to debug, it'll say like standard cout or standard variable, and I thought that was a little confusing when I was starting out, but it just means that that variable belongs to that namespace. There's nothing special or different about it having the standard colon in front of it. It's just doing the namespace, using namespace standard without actually explicitly writing it at the top. Okay. So let's take the last few minutes then, if nobody has questions, to talk about inheritance, and then we'll go into more detail about it on Wednesday. Okay. So let's go back over here. Let's ignore that. So, with the way I have that game set up right now, I have a game object, and then I create a player and I create an enemy, but I can't really make a distinction between player and enemy aside from their character that I'm using to print them right now. So if I wanted to do something where I gave unique attributes to the enemy, or I gave unique attributes to the player, I'd have to write my own class. And that might not be a good thing. Because if I was to go back really quick, and I said, well, I want the player to be able to handle the movement on their own, or I want the player to have specific actions like, jumping or diving or, whatever, then if I throw that in there in the game object class, then all the enemies and items and stuff like that also have access to it. And that's not really something I want them to have, because they're not players, so they shouldn't have access to anything that the player specifically needs, and it's also kind of bad for organization to just throw all my code into one big class file and then just figure it out and, let nature take its course. So I might think at first to just make a class called player and be like, oh, well, if the player, I wanted the player to do, I don't know, a jump, void jump. We'll make this public. Well, now I have to do a bunch of other stuff. I have to give it a position. I have to give it an ID. I have to give it a character to print with. I have to copy all of this stuff all over again, write it all down. And then there's also the problem of, well, now if I do that, whenever I create a player, it doesn't have access to the same count as the game object did anymore, right? So I kind of lose that convenience that I had of just storing a variable in a single place and dealing with it. So creating a new class for a player is going to be really annoying and kind of just awful to work with. So maybe that's not a great idea. But doing the alternative of just throwing stuff into the game object class and then only using what I need is also kind of bad practice. So instead, we have a way to do with that. So let's go back here. So I'm going to do this example with something else just because I think it's a little more common sense. So if I go back to that example that I did last week where I had an animal class. An animal might have some attributes like an age and a name. And I expect no matter what animal I'm using, it's going to have those two things. So whether it's a fish or a dog or a bird or whatever, they all can have those two things. But all animals are unique, right? They have attributes that only they have. So birds have feathers, or cats have whiskers, or fish have scales. So I might want to do something where they have the information about what they are, being an animal, but I can kind of extend off of it and maybe add more things to it. So the way we do that is with inheritance. So what I'll do here is maybe create some more classes that are just going to piggyback off this. So I might have a cat, and the cat has an integer called whiskers. And then I might have a fish. And the fish has a few things. It has... Oh, whoops, I didn't even write that in the right place. The fish has an integer for scales. And it maybe has the ability to swim. So it'll have void swim. And that's a function. And, you know, maybe a cat knows how to swim, but let's just say a fish in this case is the only thing that knows how to swim for some reason. So I only need the fish to have the swim function. And then I have a bird. And the bird has an integer called feathers. Let's call it feet because I can't fit it in there. And then the bird also has the ability to fly. So void fly. So these are all things that are unique to these specific animals, right? But I want them all to be able to get the same information that has an animal, or that an animal has. And, you know, if I was to go and make all those individual classes, like I was saying earlier, just copy and paste the data every single time, it kind of becomes annoying because they don't necessarily have access to the same exact type of variable every single time. I have to copy and paste it every single time. And if I was to update this and say, well, now I want to keep track of a weight for all the animals or something like that, now I have to go and copy and paste the weight into all these other classes and try to deal with it. And that's just not fun. So what we can do is we can say, let these things borrow from it. So let the compiler automatically put these in there and also have them all reference the same things. So now, if I was to make a cat class, so if I said like cat and then I just named it like Whiskers or something, it's the name of my cat. There we go. All right, Whiskers. Then Whiskers is going to have an age. Whiskers is going to have a name. Okay, Whiskers is going to have a name. Whiskers is going to have a weight. And Whiskers is going to have whiskers. Maybe I should think of a better name for the cat. What's a normal cat name? Just name it Claus. It sounds like a cat. Alright. So whenever I create an instance of a cat, I want it to have all the attributes of an animal and all the attributes that a cat specifically has. And that's exactly what we're going to do with this inheritance part. Okay, so yeah, let's actually extend that to our example. So we had a game object before. Game object. And that had, let's just say, a character called print character, which I'll just do like that. And then that had a, I don't know, ID. And then I'll throw in the count just for good measure. And it obviously had all those other functions too, but I'm just doing this for the sake of space. And it had a static int. We'll just call it C for count. Okay, and so now I maybe want specific types of game objects that have their own individual types of things. So, like we were saying, maybe we want the player to have its own things, and maybe we want the enemy to have its own things. So maybe the player has the ability to jump. And maybe the enemy has the ability to attack. Like void attack. And then, you know, maybe I have some other things that also belong in the game and should have access to this stuff, but I want them to have more specific features, like, let's just say a key. No, let's be a little bit more vague. let's say item. Okay, the item maybe has, I don't know, collect. Like it has a function that you call when you collect the item. Right? So I might want to do something like this where they all have these specific things. So we can keep going further out too. So even these are kind of vague, right? The enemy and the item aren't very specific. So the nice thing about inheritance is I can keep going out. So I might just have like a goblin or whatever fantasy enemy you want to throw in there. We'll count for sci-fi too here. We'll just throw alien. And maybe these have specific things. So this has like void, eat, void, abduct. Use your imagination. Do whatever you want. But the idea here is that these can keep inheriting as many times as we want. So, for instance, this alien class would have the ability to abduct, would have the ability to attack, like any enemy does, because it's a type of enemy. And it would also be a game object. So it would have all that code that we have where it has a character, and it has an ID, and it automatically increments the count, and does all that stuff. Right? And I could keep going. I could, do this as well. I could, say, oh, I want a key item. I want a sword or whatever. I think I'm mostly just stealing this from assignment 3 because I've seen what it looks like. It's going to look a bit like this. And then, this might have void swing or, an attack stat or something like that. So the general idea of inheritance is that we can keep going downwards and keep adding things onto it without having to copy and paste, and they can all access and look at anything that's above them. But something to note is an alien here, for instance, can abduct and a goblin can eat, but a goblin can't abduct and an alien can't eat. So even though they're both part of like the same tree, they can't, do the same thing. That at least are specific to them. So they can both attack because they're both instances of enemies, but they can't do what the other one does. So the common sense way that most people say to check, well, is that inherited from another thing, is to use the phrase is a. Is a. And I guess it kind of goes backwards up this tree. So this would go that way. Maybe it would help if I did it in a different color. So is like that, like that, and I would do it with the rest of them too. So one way I can tell whether something has inherited from another thing is whether it makes sense to say is a. So for instance, if I said an enemy is a game object, that makes sense because an enemy is a type of object in the game. But if I went the other way around and I said a game object is an enemy, that doesn't really make a whole lot of sense because, not every game object is an enemy. Like a player is a game object, right? At least just inherently. But a player is definitely not an enemy, even though it's a game object. So you can kind of tell if you just do the is a thing. Maybe that makes more sense with the animals. So I could say, for instance, a fish is an animal. A cat is an animal. A bird is an animal. But the other way around doesn't make a whole lot of sense. An animal is a cat. An animal is a fish. An animal is a bird. Those aren't necessarily true. So it's just a common sense way to tell if things are inheriting. So the last thing we'll cover is just, well, how do we do this inheritance in C++? How do we actually make the code to consider that? So here I already wrote out the beginning of a player class, and I wanted to say that the player is a type of game object, and then just give it specific stuff as I kind of need it to have. So the way I do that is just single colon, and the name of the class that you want it to inherit from. So player game object compiles. And so now if I go back to my main thing here, I can make the player more specific. I can say player. And unfortunately, C++ is a little bit mean about this. It doesn't seem to copy the actual constructors from the class above it, which is unfortunate. Most other languages will actually copy constructors as well. But it should copy everything else. Functions, like normal functions and values and all that, it will copy. So let me make this constructor really quick. I'm just going to take this and make a player Now why is this not working? Member declared at I know why. Oh, you know what? So actually it probably does let me use, or no, it doesn't. It doesn't let me do the constructor. That's still strange to me. Oh. Yeah. So does anybody know why I'm getting this error? Why it says position? It should be actually taking it. But you'll notice it says is inaccessible. So it doesn't say it doesn't exist, but it says that I'm not allowed to use it. Can anybody think of a reason why that is? And then I think I will leave you maybe with how to fix it, and then we'll call it a day. So why am I not able to access the position in the player class even though it's inheriting it from up here? Well, it has to do with the fact that this is private. So remember that we said a couple classes ago, private variables are only accessible within a specific class. Public is accessible anywhere. So the fact that this position is private means that I can't use it in any other class, even if it's an inherited class. So the way we get around that is, oh, actually somebody typed it and I just wasn't paying attention. Inherited objects are private by default. Not necessarily. All objects in a class are private by default, but if I tried to access like get character or get int, it would have worked here. At least it should have. Yeah, this resolved it. So we have another keyword. I'm sorry if you can hear that. My cat is just knocking over everything. I can use a different keyword here called protected. And protected variable means that it's private for itself and all of the values or all of the classes that inherit from it. So a protected here, now I'm allowed to use the position, I'm allowed to set it and get it and all that, and I'm allowed to set the symbol and generate the ID and call all of these things that were protected. But if I made something that was private, so we have this for an example later. If I was to keep this private, it shouldn't affect anything because I don't need the player to be able to do the move and bounce function anyways. Okay. So now I can access all of these things in any of the inherited classes, in this case the player, but I can't access this one. So just to demonstrate that this works really quick, let me do two things. So, oh no. Add to position is inaccessible. Why? It's right there. Oh, it's because it uses move and bounds. Oh no. Oh well. Let's just move this down really quick. Back down to here. That should hopefully fix the compiler error. If it doesn't, oh well. It still thinks it's inaccessible? It should run. Right? Const, but it's inaccessible. Cast from game object player to... Oh, I know why it's not allowing it. C++ is strange about this. I'm not a huge fan of the whole thing they do with this. I'm just going to comment this out and run it in a second, but in order to get it to run, I have to do this. We'll talk about this next time. That should make it run. Conversion to inaccessible base class, game object. Am I allowed to do that? No? Okay, I'm going to have to figure that out before next class. Very strange. That's why it's not calling that. But let me just comment this out really quick just so we can at least see that everything works as it should. Oh, there's too much stuff. Oh well. I think we're just going to have to leave that for next time because I'm going a little bit over. But it should copy everything over. All of the values. We'll check it next time. I'll try to resolve all this stuff. I don't know why it's giving me all these errors. Any last questions, I guess, before we go? Okay. Oh, just need to make sure. What's the difference between an int and a static int? So a static variable, hopefully I still have it. A static variable, every instance of that class, or, you know, just in general, a static variable, it just exists. It doesn't belong to any specific instance of a class. So for instance, if I did that previous example where I had game objects and player, when I have a static variable in the game object class, no specific game object keeps track of that static variable. And so in this case, count, because none of the variables need to, or none of the instances need to, like, keep their own copy of that thing. It just is kind of free floating and belongs to the game object definition in general. So it's almost like a global, but it belongs to a class. So it doesn't belong to any specific struct or class. Or I guess it does belong to a class. It doesn't belong to any specific struct or class instance. It's just there that you can use at any time. Yeah, let me pull over to that inheritance. There's that one. I'll do the other one. Question about debugging assignment, but I can wait till class is over. Okay, that's fine. I have like maybe a minute or two more if nobody else has questions, but you can always like send me a message on Discord or office hours too. So when an objective game object is created, it doesn't have that count, which is static. Yep, exactly. It just belongs to the game object class in general, but not any specific instance that I create of a game object. So the player, for instance, is an instance. Oh, that's a tongue twister. The player is an instance of a game object, but the player doesn't have the count. And the enemy is an instance of a game object, but it doesn't have the count. It just belongs to game objects in general. Now C++ does allow you to say, oh, I want the count of the player, and it will get it anyways, which a lot of other languages don't allow, which is why I don't try to explain it that way. So you are allowed to do that. You are allowed to say, I want to get the count of the player, and C++ will allow you to get it, but that's not normal, I guess. Oh yeah, sorry, let me move over to the other inheritance thing in case you wanted to screenshot it. Okay, yeah, I think I answered that question. So, I had a question about debugging assignment 1. Yeah, actually, I guess maybe even this isn't a great place to do it. Yeah, just send me a message on Discord if you're still here. Or email if that's easier for you.
I'm still here. Can I ask? Can you hear me?
Yeah.
So I'm trying to just debug it in Visual Studio. Is there a way to run it with command line arguments, or do I have to put it on Sally or Bobby and
yeah,
run it that way?
So if you're using normal Visual Studio, if you go to Project, and then whatever the name of your project is, Properties, at the very bottom there.
Yeah.
And then you hit Debugging. There's command arguments right there.
So would I have to put in still 2 arguments, like a.out and then the name of the file I'm trying to import, or just the file?
Just the file. It assumes that the first argument is whatever program you're running, because you need that.
Okay, and does that have to be in a certain location, like a certain file, or?
Just put it in the same directory as your Visual Studio project. So the way I usually just do that to make it easy is I go up here, right-click on the project name, and then go to Open Containing Folder. And then it will open it up in the File Explorer for me, and you just want to copy and paste it here.
Okay, perfect, thanks.
No problem.